Okay, so the first problem I'm going to work out will be a margin of error problem. As you see, it says a survey was conducted of the age and years of 40 randomly selected customers. The mean was 31.42 years and the standard deviation was 10.46 years. So we're going to go ahead and write out what we know. The sample size is the n equals 40. The sample mean x equals 31.42, and the sample standard deviation, which is s, equals 1046. So the first question, A, how large would the sample size have to be to cut the margin of error in half? So, at any level of significance, sorry, I can't spell, of significance, the margin of error is the equation. It's margin of ME equals Z, and we're going to do 1 for the first one times S over, let's see, I don't have a square root button, but we're going to say this means square root, so square root of n. So maybe I'll square root of n divided by, okay, so that's what we got right now. V1 is the critical test statistic, by the way. So for n equals 40, we're going to go ahead and plug in the stuff for the equation. N equals 40. The margin of error equals Z1. So we're going to put 10.46, for standard deviation. 46 divided by the square root of 40. Okay, so now we have to cut the margin in half. Now we cut the margin in half. So we are now going to do a new margin of error. Margin of error, we're going to call it new at the bottom, equals 1/2 margin of error. We're going to so now we're going to make the sample size be in new. So that'll be a new formula. Now we're going to plug in, so we'll say ME, then new, under 1/2 Z1 times 1046 divided by square root of 40 still. Then we, work that, and we get Z1 times 1046 divided by the, square root of n new. Once we work that out. Okay, and we keep going. So it will be 5.23 divided by square root of 40 equals 10.46 divided by square root of n new equals n new 1046 times square root of 40 divided by 5.23 with all squared. So we're going to do where the up arrow. Why can I never find this? There's up arrow squared. All of that equals 160. So I know it's kind of hard to see, but once you work that out, you get, so the new sample size equals 160. So that is how you cut the margin error in half. Sorry if that was a little confusing. But basically the margin of error is inversely, proportional to the square root of sample size. So by that, if margin of error is in half, the n must be squared sorry, I'm having to think this through. Okay, so if the margin of error is in half, the n must be squared 2 times the previous one, times the previous one. 3 times the previous one. Alright, maybe I can explain part B better, but about how large would the sample size have to be cut, the margin of error, by a factor of 4. So what we're going to do now is say if we cut by the factor of 1/4, n should be 4 squared equals 16 times. So, sorry, 16 times larger. So n should equal 640 because, hold on, 1 times. So that should be it. That is how you solve the margin of error in half and cut the margin of error by a factor of 4.